There are a huge number of cosmic objects in the universe, from tiny asteroids to giant planets. Some of them have already been studied enough, while others remain a mystery. Many objects are still waiting to be discovered. Today we'll talk about one of the coldest, darkest, and most remote places in the solar system, the planetoid Sedna. At the end of the 20th century, there was a significant breakthrough in the study of remote corners of the solar system. Since the 1990s, 3,555 celestial bodies have been discovered beyond the orbit of Neptune. Most of them are small objects composed of water ice and frozen gases such as methane and nitrogen. These trans-Neptunian objects form different regions around the Sun, such as the Kuiper Belt, the diffuse disk, and presumably the Oort cloud. The Kuiper Belt surrounds the solar system as a large ring at a distance of 30 to 55 astronomical units from the center. It is similar to the asteroid belt, but 20 times wider and up to 200 times more massive. The Kuiper Belt is mostly made up of remnants left over from the formation of the solar system, although there are also quite large objects such as Pluto, Charon, Haumea, Makemake, and other planetoids. The diffuse disk is a region with less clear boundaries. Objects belonging to this region have orbits that are highly elongated or close to the ecliptic. The largest object in this region is the planetoid Areta. However, today we will focus on another object that also deserves our attention, the dwarf planet Sedna. Sedna was discovered on November 14, 2003 by American astronomers Michael Brown, Chadwick Trujillo, and David Rabinowitz. At the time of its discovery, it was considered the second largest object beyond the orbit of Neptune, second only to Pluto. However, Sedna later became the fifth largest known trans-Neptunian object, after Areta, Haumea, and Makemake. Sedna's orbit around the Sun is highly elongated, and its perihelion is 76 astronomical units, to 0.5 times the radius of Neptune's mean orbit. Sedna's aphelion is 942 astronomical units away from the Sun, making it one of the most distant and coldest objects in the solar system. It is due to these characteristics that the planetoid got its name, in honor of the Inuit goddess of sea animals. Sedna completes a complete revolution around the Sun in about 11,500 years. At the time of its discovery, it was at a distance of 89.6 astronomical units from the Sun, which is almost twice as far away as Pluto. Sedna is now traveling toward the Sun and will reach perihelion around 2076. Sedna has a diameter of about 1,000 kilometers. That's about 40% of Pluto's diameter and slightly smaller than Charon. Sedna has no satellites, making it difficult to accurately determine its mass, which is estimated to be between 1 and 10% of the Moon's mass. More accurate data can only be obtained with the help of a special expedition to the planetoid. Sedna's rotation period around its axis is about 10 hours, and the planetoid's bright red surface reflects about 30% of the light falling on it. Spectral analysis shows that Sedna's outer layers consist mainly of water ice and frozen gases such as methane, ethane, and nitrogen. These substances, when exposed to ultraviolet radiation, form tholins, organic polymers containing nitrogen, which gives Sedna its characteristic bright color. Over the next 200 years, Sedna will be relatively close to the Sun, and its temperature will rise to 35.6 K, or minus 137.6 degrees Celsius. At the same time, some of the gases on its surface may begin to vaporize, resulting in a much thinner atmosphere. However, even at the most optimistic times, the density of the atmosphere will be 70,000 times less than on Earth. Sedna is considered a very distant object, but there are other objects in the solar system that are even farther away. For example, Object 2018 AG37, also known as Far Out, was detected at a distance of 132 astronomical units from the Sun and is considered the most distant object in the solar system that has been observed directly. There are many more comets and other celestial bodies with elongated orbits and long orbital periods that are still waiting to be discovered. Who knows, you may be the one to discover something new. Friends, your support is very important to us. Share your ideas about what other objects in the solar system would be interested in exploring, and feel free to leave your comments.